one told me.
The answer on this one is -8. Answer to this one should be -2. Answer should be a -25.
We need more red paper.
We have 4 out of 8, which is 50%. If you had credit for your homework, pick a number from 1 to 20. And the new rule is if there is less than 50%, if there's 50% or less on the homework participation, then you get to pick 2 numbers for those who have it. So you can pick 2 numbers from 1 to 20 on the same piece of paper and drop them off now. The winning numbers are 4, 9, 13, 16, and 18.
Definitely not.
Multiple choice, block letter only. Answer for this one is A. Homework answers. You get 1 point for the zeros if you have both of them, -3rd and -1. 1 point for the axis of symmetry, which is -2/3. And 1 point for the vertex, which is -2/3 and -1/3. Here's the graph for number 1. Number 2, the zeros are -2, -1. Axis of symmetry is -3/2 or a -1.5. And the vertex is -3.5 and a half. Here's the graph for number 2. And number 3, you should have zeros of -0.6 and -1.1. And then axis of symmetry is -1. The vertex is -1, -1. Here's the graph for number 3. Here's a new one today, the rational root theorem. So before, we have found roots or zeros or solutions, whatever you want to call them, by using factoring, and we've used the quadratic formula. Now you have the rational root theorem. So here's example 1. So for this one, this is f of x equals 4x squared minus 5x plus 6. And we want to find a list of all possible roots for this. Notice I said possible. Some of them may not work out, and we're not even going to know that yet because we're just going to make the list of possible roots. The first step you have to do in finding the list of possible roots is to look at the constant in the polynomial. And the constant is the back end. It's where there's just a number. Some of the possible roots of your polynomial will come from the factors of 6. And they're going to be plus or minus. So can you give me a number that comes out of 6? What's a possible factor of 6? The very first one. Before that. 1, yes. So put plus or minus 1. What's another factor of 6? 2. What's another factor of 6? What's another factor of 6? That's right. And you put plus or minus in front of all of them. Now those by themselves will be possible roots of this polynomial. Plus or minus, there we go. But now to find the rest of the possibilities, you have to do the following. You need to repeat this list here the same number of times as factors that you have from your leading term. And this is the coefficient on the outside term on the left. So off to the side here, we're going to have to make the factors of 4. Now the factors of 4 don't automatically mean they're going to be roots, but we just need to have the list so that we can use them with everything else. So what are the factors of 4? 1, and you don't have to write plus or minus right now. 1, what else? 2, and 4, right. Now what you're going to have to do for every factor that you came up with from 6, your back term, you've got to divide those by each of these separately. When you divide by 1, does it change anything? No, so we don't even need it. And in the future, you don't even have to write it. How many factors of 4 do we have that we're going to use? 2, right. So that means I need this list 2 more times. So we'll go ahead and write that. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4. And then do it again. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Clearly it's not going to be 6. It's going to be, or not 4, but it's going to be 6. So that's my fault, just a typo. But now what you have to do is go back through and divide everything by 2 and 4. Don't forget that this stays as it is. Whenever you find these factors, those are possible factors of your, or possible roots of this polynomial. So leave this alone. We have 2 factors of 4 that we're going to use. That's why we have 2 more lists here. And here's what you do. Start with the 2 there and divide everything by 2. And then move to the 4. Divide everything by 4. Are there any of those fractions that can be reduced? 2/4 can be 1/2, that's right. So change this to plus or minus 1/2. Is there anything else that can be reduced?
6/2 can be reduced to 3.
Yeah, that's right. This could be plus or minus 3. Anything else that can be reduced?
2/2 could be reduced to 1.
That's right. This can be reduced to 1. Anything else? How about 6/4? 3/2. Yeah, you can make that 3/2. Is there anything else that can be reduced? All right, that's it. Everything's reduced. But do you see duplicates of numbers? And we're looking at all 3 lines now. Do you see any duplicates of numbers? If you find duplicates, then you must cancel out one of them. So we'll do it this way. I'll increase my marker. What's a duplicate that you see?
1/2.
Yeah, I have a 1/2 here and here. So I'm going to take one of them out. It's going to be this one. And we'll just scratch through the rest of that. What else is a duplicate? 3/2, yeah. So I'm going to keep this one and scratch this one out. What else is a duplicate? Yeah, 3, plus or minus 3. So here it is, and here it is. So I'm going to take out this one. What else is a duplicate? Plus or minus 1. Yeah, here they are. So I'm going to take this one out. Any more duplicates in there? No. So your list of possible roots are going to be plus or minus 2, plus or minus 6, plus or minus 1/2, plus or minus 1, plus or minus 3, plus or minus 1/4, plus or minus 3/4, and plus or minus 3/2. Here's another example. This one is f of x equals 8x squared minus 2x and plus 10. So where do I start? Yeah, we go to the 10. And all of its factors will be possible roots of the equation. So what are the factors of 10 in order from left to right? 1, 2, 5, and 10. Alright, so those stay. Those are staying with it, and we're done with those unless we have to cancel any of them out later on. So now where do we go? We have to go to the 8. So there's the 8. And are the factors of 8 automatically going to be possible roots? No, we just need them so that we can do what with them? We can factor them out, and after we factor them out, what would we do with them? Yeah, that's right, divide them into the other ones. So let's find them first. 1, 2, 4, and 8. Which one don't we need? 1, so those are gone, or it's gone. So remember, we need 1, 2, 3 lists. We already have 1 on there. Now we have to divide these lists of numbers. Don't forget, this one stays as it is right there. But these 3 lists, we got to divide them by 2, 4, and 8. So if I divide this one by 2, and then this one by 4, whoops, that's a 4, and then this one by 8, what do I have to do next? Simplify, yeah. So is there anything in this first row that needs to be simplified?
Yeah.
Which one?
No,
No, not that one. So we'll go a term at a time. Do we have to simplify this one?
no.
What about this one?
Yes.
What is it? 1, yeah, so we'll go plus or minus 1. And then what about this one? No. What about that one?
Yes.
Yes, what is it? 5. So we'll go plus or minus 5. And then what about this one? What about this one? What is it? It's a half. What about this one? That one? What is it? 5 over 2. And then what about this one? What about this one? What is it? 1/4. What about this one? This one? What is it? 5 over 4. Okay, now do you see any duplicates in here? Alright, so what's the first duplicate? 1. We'll mark out this 1, and it shows up one other time, so we're done with that. Are there any other 2's in there? What about 5's? Yeah, so we'll take this one out. What about 10's? Are there more than 1 half? Yes, there's a half there, and we'll leave the other one. Is there more than 1 5 over 2's? Yeah, that's gone. What about 1/4? Yeah. And what about 5 over 4? What about 5 over 2? No. What about 1 over 8? 1/4? And 5 over 4. So that's it. There's all of your factors.
So does it like plus or minus?
Yeah, you must always use plus or minus in front of them.
What about the 5 over 8?
5 over 8, do we have 2 5 over 8's in there? No, so we'll just leave it. So you end up having 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible roots of this polynomial. How many factors of 24 are there? Just you can list them out, but I need the total number of factors. That's the answer I'm looking for. Answer for this should be 8.
Finding it out, 'cause
The answer to this one should be 10.